Today we're going to learn about something pretty cool, which is called elasticity. And it's something that most of you haven't seen before, so it's new stuff. It's not review anymore. Just to remind you, this is really your lecture material, so you must take notes on the video. It's a good idea that when anything that's written on the screen, you write it down. You can summarize it if you want. You can elaborate in certain cases. And you're going to show it to me later on at the end of the term to impress me. It's also a good idea to write this, slide number at the top left corner just for your own future reference. When you hear the word elasticity, what do you think of? Elastic? Yeah. Now, if you think of an elastic, it's a pretty cool thing. You can do a lot of fun stuff with it. What's so special about an elastic is that it responds. It responds to you when you stretch it, right? And that's really the essence of elasticity. It is really responsiveness, or if you want, sensitivity. So it's the responsiveness of quantity demanded or quantity supplied to its determinants. If you remember, the law of demand says that when the price of something goes up, the amount people buy will go down, other things being equal. The question is, by how much? Yeah. So does the quantity go down a lot or a little? And that's really the responsiveness, okay? Or think of a spring. A spring, kind of like an elastic, if you stretch or compress the spring, it's going to respond, right? But some springs are more rigid and some springs are more flexible, all right? So that's really the elasticity of the spring. So it really depends on the product's price elasticity of demand, which is how much the quantity demanded of a good or service responds to changes in its price. And the main condition is, can you do without it? How easy is it to substitute it with something else? So if there's a product where you can easily substitute away from it, it's elastic, all right? Or you are elastic. If it's something that you can't really change and you're stuck with it, then it's inelastic. All right, so you might want to pause here and take some notes and record the slide number. Talking about responsiveness, let's watch a funny clip and notice how quick the reflexes of this guy is.
Stop! Stop! Where did that rat come from?
He must have brought it in with him.
Damn it! Man, is he dumb. Where do they get these subjects?
He's a little too well fed to be a wino.
There are some different types of elasticity, and the most important one that we're going to focus on the most is price elasticity of demand. Basically, how responsive is the quantity demanded to the price. So it depends on a bunch of things. One of them is the availability of close substitutes. A good with close substitutes has more elastic demand. So remember substitutes like Coke and Pepsi, right? Coke and Pepsi are very close substitutes. If the price of one of them goes up, people are gonna quickly switch to the other one. So that's very elastic. Another element is whether the good is necessary or luxury. Okay, a luxury good has a more elastic demand. So think of some luxury item. I don't know, like a Gucci bag. Can you live without a Gucci bag? Yeah. If the price of it goes up, if you feel like a luxury product is a ripoff, well, you don't have to buy it, right? And you can switch to something else. Yeah. But if it's a necessity, if it's, let's say, water, if the price of water goes up, can you live without water? You're kind of stuck. You have to pay for it because it's a necessity. Another element is whether you have a narrow or a broad market definition. So basically, it's easier to do without very particular or narrow products, and that's going to have a more elastic demand. So let me explain to you what we mean here by narrow and broad. Think of vanilla ice cream. Can you live without vanilla ice cream? Yeah. If the price of vanilla ice cream goes up, can you switch to something else? Yeah, I mean, you can switch to another flavor, right? What is something broader than vanilla ice cream? Well, ice cream in general. Yeah, so that would be a broader market definition. If the price of ice cream goes up, what are you going to do? Well, you can switch to some other dessert, right? So there are other, so a more general, a broader category of ice cream is dessert. What's a broader category of dessert? Well, food in general. Yeah. So can you live without food? Well, okay, at this point you're like, oh no, if the price of food goes up, then you're kind of stuck. You have to buy it anyway, right? You could live without vanilla ice cream, but you can't live without food, right? So that's what we mean. So narrow things are more elastic because, it's not the end of the world. But broad things, you can't really escape from that. And another element is time horizon. So with more time, consumers can substitute and switch easier. So the demand is going to be more elastic over longer periods of time. So here's the thing. Let's say you drive out in your father's car and you notice that the price of gas is higher and you need gas. Well, if you need gas that way, you have to buy it, right? Even if it's too expensive. But if the price of gas stays high for a long time and you're given the time, then you can kind of plan ahead and can say, okay, you know what? Today I'm going to take the public transit, or we're going to carpool, or we're going to take the bike. Yeah. So if you're given time, you can find other solutions. If you don't have enough time, then you're inelastic. You can't respond quickly. Pause here. Let's do some fun stuff. We're going to draw the demand curves for elastic and inelastic items, and we're going to see the difference. So when we talk about inelastic means that people would buy it no matter what's the price. A good example of that would be something addictive. What is something addictive? Cigarettes? Well, you can do better than that. Let's say crack. Yeah, I hope I don't get into trouble for this. So the demand for crack would be fairly steep. Okay, and inelastic demand is steep. Now, what is something elastic? Something that's not addictive. Let's say crackers. Yeah, so crackers are not that addictive, and the demand for crackers would be fairly flat, right? So elastic demand is relatively flat. Now, how does that work? So how does that make a difference? So let's look at a price. Let's say they start at the same level of price, and then the price goes up by the same amount in both markets. What's going to happen is we know by the law of demand that the quantity is going to drop. Yeah. So the quantity demanded for crack goes down. The quantity demanded for crackers also goes down. But as you can see, the size is not the same. One of them goes down a lot. One of them goes down by just a little. Right? So notice that the price change is the same in both cases, but the quantity change is not the same. The quantity of A goes down only a little bit. The quantity of B goes down a lot. And that's the whole idea of responsiveness. Product A is not very responsive. Product B is very responsive. It changes a lot. All right. So pause here and draw your graphs just as you see side by side. Do the dotted lines. Do I need job with a ruler? This is a useful practice. Wow, origami. So we're going to look at the formula for price elasticity of demand. What it is the percent change in quantity demanded over percent change in price. So if you don't like the short form, you can write it out. Okay, so what it's showing is the percent change in quantity over the percent change in price. By the way, these signs, the lines that you see around, that's the absolute value, which means that you drop the sign, right? So you would know that it's always negative because the law of demand tells us that if the price goes up, quantity goes down. They move in the opposite direction, but we're going to ignore the sign. Okay, so this is a very useful formula. When you write it down, box it or highlight it because you're going to use it later. And again, if you don't like that notation at the top, you can just write out the words. Okay, remember the percent change formula, which is the same as the rate of growth. That's when you have the second value minus the first value over the first value times 100. So second value could be the price in the second year minus the price in the first year over the price in the first year and times 100. With the quantity, you do the same thing. Okay, so write this down. All right, let's look at an exercise as practice. Dina used to buy 10 ice creams per month at price of $1, and when the price rose to 1.10, she started buying 8 ice creams. What is her price elasticity of demand? Okay, this is a simple question, and some of you are better than others in math. I'm going to show you systematically how to solve problems in a very neat way. Make sure you take your time to write down everything, show your work, show the formulas that you use, then plug in the numbers. Don't rush yourselves, go step by step. So I'm going to walk you through, make sure you follow. Some of you may need to watch this slide again. So what we're going to start with is we're going to start determining what we know and what we don't know. So the first thing we're told is that she used to buy 10 ice creams, and that's quantity demanded 1. That's the initial quantity. And the price was $1, so that's P1. Okay, then the price rose to 110, so that's P2. And at that point, the quantity went to 8, so that's Q2. So these are the pieces of information we're given. What we're asked to find is the price elasticity of demand. So whenever you have a question, write it down like this, like in a column, write down what you know and what you don't know. This is going to make your life easy, and you get partial marks for it, and it's less likely for you to make a mistake later. Okay, so now let's move on. We need to find ED, right? So if you want to find this, the first thing you do is write your formula. So the formula for price elasticity of demand is percent change in quantity demanded over percent change in price. And we have to find each of them separately. So first of all, let's find the denominator. The percent change in price is P2 minus P1 over P1 times 100. And we know that. We know P2, we know P1. We already wrote it down on the left side. So it's 1.10 minus 1 over 1 times 100. And if you punch that in, you're going to get 10%. And you convert that to decimals, what do you get? 0.10. Yeah, so you should be able to convert decimals to percentages and vice versa. Similarly, you do the same thing for quantity demanded. It's the same formula, Q2 minus Q1 over Q1. So it's 8 minus 10 over 10 times 100, and that's going to give you minus 20%, which is the same as negative 0.2. All right, now that we have that, we can go back to our initial formula and we can plug in the values, right? So we have negative 0.2 over 0.1, and remember we have absolute value signs around it, so we don't need to worry about the negative sign here. So what you get is 2. All right, whenever you do a problem, box the final answer just to show that this is my last answer, and write a short sentence to interpret that. So in this case, it is Dina's price elasticity of demand for ice cream is 2. Okay, when you do the math, try to keep all the decimals. This question is easy. Sometimes you get decimals. Try to keep more decimals than less. This is going to be more accurate. And at the end, the rule of thumb is keep 2 decimal places. 2 decimal places is a safe way of doing things. So we go with that. Okay, usually the question tells you how much decimals to keep. So pause here. You might want to watch it again. Write down the full process, and this is how you're expected to do problems. Ranges of elasticities. Remember again that elasticities, these values are in absolute value, so we don't worry about the negative sign. So elastic is the same as responsive, and that's when the quantity demanded changes more than the price. And that means that the price elasticity of demand is going to be more than 1. Voila. The opposite of that is inelastic, which is not responsive, and that's when the quantity demanded changes less than the price. And that's going to result in a price elasticity of demand which is less than 1. Right? So it's like, oh no, I can't pull it, it's so hard. So that's inelastic. Did you miss anything if you have more than 1, less than 1? Well, what about just 1? Yeah, so that's called unit elastic, which means it's just as responsive. So if the price goes up by 10%, quantity goes down by 10%. It's the same ratio. And then there are 2 extreme cases, which are more theoretical. It's called perfectly elastic, which means very responsive. So a small change in price will change quantity demanded by an infinite amount. Okay, so the price elasticity of demand would be infinity. Now you might be like, hang on, is that ever gonna happen? Well, yeah, it could happen. I mean, again, this is more theoretical, but think of vending machines. If you have 2 identical vending machines next to each other, and the price of one of them goes up even a little bit, then people are going to buy from the other one, right? Or 2 stores that are next to each other, or gas stations which are across the street, right? You can just easily switch. Perfectly inelastic is the opposite, so that would be not responsive at all. So that's a very rigid demand. So no change in price will change quantity demanded. You always demand a set amount regardless of price. So that's not responsive at all. Think of like necessities. If you were to pay for some medicine and you really need it and there is no other substitute, then you're gonna buy it no matter what. Okay? You're gonna find the price to pay for it. Pause here. In the price elasticity formula, we had percent change in price and percent change in quantity. And you know that formula, P2 minus P1 over P1 times 100. Now, just for elasticity questions, we're not going to use P1 in the denominator. We're going to use something else called P mid. Okay? And you should be able to guess what is P mid. P mid is simply the average of price 1 and price 2. Okay, so P1 plus P2 over 2. So you use the average price instead of the P1 in the denominator. And we also use the same thing for quantity. Okay, we use this for more accurate results. So this is only applicable to elasticity questions. Whenever you have a question, you always use the midpoint method. And the midpoint method, all it means is that in the denominator, you're going to use the P mid instead of P1. Okay, so if you want to simplify the formula, you get something like this: Q2 minus Q1 over Q2 plus Q1 over P2 minus P1 over P2 plus P1. So that's a useful formula. You can use it to do the problems. So by default, you always use the midpoint method unless you're told otherwise. Pause here. Another type of elasticity is income elasticity of demand. So far we talked about price elasticity. Now we're talking about income elasticity. The idea is the same. It's about responsiveness, but responsiveness to something else. So how responsive is quantity demanded to a change in income? How much more you would buy if you had more income? How sensitive your consumption is to your income? Or the role and share of income in your demand for a product, right? So sometimes you're like, oh no, I don't have money anymore. But it's not going to affect your demand for certain things that much. Okay, you're going to buy them even if you're broke, right? In other items, if you don't have income, then you won't buy it. Okay, so that could differ based on the products, and that's the whole point of elasticity of income. So the formula for that is the same format. It's percent change in quantity over percent change in income. This is a bizarre notation for income in economics. And that's what we use because I is used for investment or for interest rate. So if you like, you can also write it out in words. So percent change in quantity demanded over percent change in income. The rules are the same as before. You still use the midpoint method. So when you do the percent change formula for quantity and the percent change formula for income, you still use the midpoint method. Okay, so that's a useful formula. Write it down and box it or highlight it. The only difference here, and you want to watch out for this, is that there is no absolute value. Okay, so you don't have absolute value in income elasticity. Now think of this: would this be positive or negative? Okay, or in other words, when would it be positive and when would it be negative? Think about that question. That could be a test question, and you should be able to figure it out. When would income elasticity be positive and when would it be negative? Both of them are possible, and you should be able to figure that out. Another type of elasticity is cross-price elasticity of demand. And cross-price means price of something else. So how responsive is quantity demanded to a change in the price of another product, not the same product? And that depends on how related they are. Okay? So the general formula, this is very similar to the formula for the price elasticity. Here we have products A and B. We are comparing two products. So if you want to write it out in words, it means the percent change in quantity demanded of good A over the percent change in the price of B. So in the numerator we have product A, but in the denominator we have product B. Okay, so it's about the relationship between them. So that's a general formula to write. Now think about, again, we don't have the absolute value sign. Sometimes this is positive, sometimes it's negative. And when we talk about related products, there are basically two types of relation between products. One of them is substitutes, and the other one is complements. Yeah. So substitutes are like what? Like Coke and Pepsi. Yeah. If the price of Coke goes up, what happens to the quantity demanded of Pepsi? Would people buy more Pepsi or less Pepsi if Coke is more expensive? So if A and B are substitutes, then the cross price elasticity is going to be positive. If they're complements like shoes and socks, if shoes become more expensive, what happens to the demand for socks? The quantity for socks, the quantity demanded for socks is also going to drop, so there's going to be a negative cross price elasticity. Okay, so you should be able to explain these if you're told in terms of the logic of why one of them is positive, why the other one is negative, and it just has to do with the demand shifter. So go back to your demand shifters, review the substitutes and complements. You should be able to figure it out. Pause here. Next, we have the price elasticity of supply, which is pretty much the same thing, only on the supply side. So that's the responsiveness of quantity supplied to changes in price. If the quantity supplied responds a lot to a change in price, then that would be an elastic supply. If it doesn't, then that would be an inelastic supply. It depends on the seller's flexibility to change how much they produce. So if the sellers are really flexible, if the producers of a good or service can easily modify their quantity, then that would be elastic. If they can't, then that would be inelastic. And the main determinant for supply is really time. If you give them time, then they can expand their production. They can, build more factories or more production lines and so forth. So a general rule in all elasticity is that things are more elastic in long run. Okay, so you might want to write that down. It's a kind of an important thing that the time frame that we're talking about makes a lot of difference in terms of elasticity. The formula in terms of format is the same thing, percent change in quantity supplied this time over percent change in price. And you can write that in words also. So in terms of sign, you have to remember the law of supply. When the price of something goes up, the quantity supplied also goes up. So the sign here is always positive. We can also illustrate this graphically. So kind of like what we did with demand, we're going to have two graphs, one for inelastic supply and one for elastic supply. So an example of something which has an inelastic supply would be land. Land has a fixed quantity, right? If the price of land in an area, let's say you are talking about a beach where the land is very pricey, you can't really add to that land. I mean, you could make some artificial land, but it's not that easy. Okay, so the supply for that would be fairly steep. Something that's elastic would be pretty much most products have elastic supply. Let's say electric cars. In the past few decades, the production of electric cars has increased a lot, and part of that is because the price for them has been pretty high. There's a lot of demand for them, so the producers can easily increase that. Let's say you're a car producer. Let's say you're Honda or Toyota or whatever. If you notice that there is good demand for electric cars, if you see that they're selling very well, you can easily change your production lines. So you can take some of the assembly lines from trucks and allocate it to electric cars. So the supply for that would be fairly flat. Okay, you can also illustrate this with some values. So let's say there's an initial price for each of them, and then the price goes up. What happens is that the quantity supply goes up in both cases, but not by the same amount, right? So in the inelastic case, there's a little increase. In the elastic case, there's a lot of increase. The change in price is the same change in both cases, but the change in quantity is much smaller in A than in B. Okay, so again, draw two diagrams side by side and do the dotted lines, do a neat job with the graphs. Time for practice. The price of oil rose from $80 per barrel to $100 per barrel, and oil producers raised their output from 9 million to 11 million. Find the price elasticity of supply using the midpoint method. So this time you're using the midpoint method, and just like before, do it in a very systematic way. So look for what you know and what you don't know, right? The first thing that we are told is that the initial price was $80 per barrel, and the final price was 100. Okay, so that's P1, P2. Then the initial quantity was 9 million, and the final quantity was 11 million barrels, right? By the way, the M stands for million. You don't need to put 6 zeros. You can just put M, and the M's are going to cancel out, so you don't need to worry about it. And the BR stands for barrels, okay? So that's just a unit of volume. Again, you don't need to worry about that either because it's always the same unit. As long as you're dealing with the same units, they're going to cancel out, so you don't need to worry about it. What we have to find is the price elasticity of supply. Okay, so always do it in the same way. Write out what you know on the left-hand side and what you want to find out. Then the first thing you do is write the formula for what you're looking for. So in this case, we are looking for the percent change in quantity supplied over percent change in price. You have to find those separately. So starting with the denominator, we have the same formula as before, except that this time we have the midpoint method. Okay, so the P mid is in the denominator, and P mid is the average of P1 and P2. Okay, so you can plug in your numbers, and in the denominator you can see that we are adding up the two values and then dividing by 2. If you punch in these numbers, you're going to get 22.22222 forever, and I'm just going to write it out in decimals, 0.22. Okay, it's better to keep more decimals always until the last stage. Okay, so general rule in all courses actually, whenever you do math, keep decimals as much as you can until the very last final answer. That's going to give you a more accurate result. But overall, the questions that you get always have a good tolerance of decimals, and you're always told how many decimals to keep. Okay. The quantity supplied follows the same procedure, so you plug in the numbers. Notice again that we are using the midpoint method in the denominator. And if you do the math, you get 20%, which is 0.2. Now we go back to our initial formula, and we plug in the numerator and the denominator. And if you have enough decimals, you're going to get 0.90. All right, so that's our final answer. And you write a sentence saying that the price elasticity of supply for all producers is 0.90. And again, notice here the value is positive because the law of supply tells us that when the quantity supply, when the price goes up, the quantity supply goes up also. The 0.9 is less than 1, and if it's less than 1, it means it's fairly inelastic. Right, so quantity supplied for oil doesn't really respond that much to the price of oil. That's what it means here. Pause here, write down a full solution for yourself.